Hi guys, welcome to another grade 11 video, Euclidean Geometry still. Today we're going to be treating a different question paper. Let's get to it. The problem statement reads as follows. In the diagram below, O is the center of the circle and point T lies on the chord RS. Prove the theorem which states that if OT is perpendicular to RTS, then RT is equal to TS. Let's get to it. First, we construct radii, OR, and OS, as you can see on my diagram. Next, I go on to say in triangle OTR and triangle OTS. I've also highlighted the triangles in question in my diagram, as you can see in orange. OR is equal to OS. They are both radii of the circle. OT is equal to OT, that is a common side to both my triangle. And finally, angle T1 is equal to angle T2, and they are both equal to 90 degrees. Angles on a straight line was the reason I used, and hence I can conclude that triangle OTR is congruent to a triangle OTS. Moving on to question 9.2. The problem statement reads as follows. In the diagram, O is the center of the circle ABD. F is a point on chord AB such that DOF is perpendicular to AB, and AB is equal to FD, and they are both equal to 8 centimeters, and side OF is equal to X centimeters. Determine the length of the radius of the circle. Let's get to it. AF is equal to FB, and they are both equals to 4. My reason was radius is perpendicular to chord, and it bisects the chords, cuts the chord in half. Next, I went on to say OB is equals to OD, and they are both equals to X. The reason was radii. They are both radius to the circle. And I went on to use the Pythagoras theorem. OB squared is equals to OF squared plus FB squared. Pythagoras is the reason, and you can see the triangle in question. I've highlighted it in orange. And substituting in everything I know, OB is equals to 8 minus X squared, and X squared, that is equal to X squared plus 4 squared. I've substituted in OF and FB as well, as you can see there. And to expand the left hand side, 8 minus X into 8 minus X equals to X squared plus 16X. And hence 64 minus 16X plus X squared is equal to X squared plus 16. And X squared minus 16X equals to 16 minus 64. All I did there is group the like terms. And I'm going to be left with negative 16x is equals to negative 48, and hence x is equals to 3. But I'm not asked to find the length of x. I'm asked to find the length of the radius. But radius is represented by the equation 8 minus x, and substituting in the x value that I found, radius equals to 8 minus 3, which is equals to 5. Moving on to question 10. Which the problem statements read as follows. M is the center of the circle SVQR, having equal chords SV and QR. RP and QP are tangents to the circle R at R and Q respectively, such that angle RPQ is equal to 70 degrees. 10.1. Calculate the size of angle R2. Let's get to it. First step, I went on to say angle side RP or tangent RP is equals to tangent QP. They are both tangents to from a common point outside the circle. Second, I went on to say angle R2 is equals to angle Q2. Angles opposite equal side. If you can see, if you look at triangle PQR, it's an isosceles triangle, and hence R2 and Q2 are base angles, and they should be equal. Moving on, I went on to substitute in everything I know in my triangle. Angle P plus angle Q2 plus angle R2 is equal to 180 degrees. Reason sum of angles in a triangle, and you can also see the triangle in question in the left hand side. Substituting in everything I know, 70 degrees plus 2 angle R2 is equal to 180 degrees. And hence angle R2, 2 angle R2 rather, is equal to 180 degrees minus 70 degrees. And hence R2 is equal to 110 degrees divided by 2, which is equals to 55 degrees. Moving on to 10.2. Calculate the sides of angle Q1. Angle Q1 plus angle Q2 is equals to 90 degrees. Tangent is perpendicular to radius. It's a theorem. And hence angle Q1 is equals to 90 degrees minus 55 degrees. And hence Q1 is equals to 35 degrees. Moving on to 10.3. Determine the sides of angle M2. First step, R1 is equals to angle Q1 and they are both equals to 35 degrees. My reason was angles opposite equal sides or base angles of an isosceles triangle. As you can see, I've highlighted the triangle on the left hand side. And I went on to say angle M1 plus angle Q1 plus angle R1 sum up to give me 180 degrees. My reason was sum of angles of a triangle. And substituting in everything I know, I'm going to be left with M1 is equals to 180 degrees minus 2 angles times 35 degrees. I've substituted in and I've also kind of made M1 the subject of the formula in this same step. So make sure that you see and follow what I did there. And solving that, I'm going to be left with angle M1 is equals to 110 degrees. And angle M2 is equal to angle M1 and they're both 110 degrees. My reason is that equal chords subtend equal angles at the center of the circle. That is a theorem. Moving on to question 11. The problem statement reads as follows. In the diagram below, O is the center of the circle. CDE is a tangent to the circle at D. DB bisects angle ABC. Let angle B1 equals X. 11.1. Prove that BC is parallel to OD. Let's get to it. Angle B1 is equal to angle B2 and they are both equal to X because DB bisects ABC. As you can see on the problem statements, they've told me that. And I went on to say angle ABC is equal to B1 plus B2 and is equal to 2X. I've added up the two equal angles. And I went on to say angle O1 is equal to 2 angle B1 plus, which are both equal to 2X. My reason was angle at the center is equal to double angle at the circumference. That is again a theorem that you need to know. And hence BC is parallel to OD. My reason was corresponding angles are equal, which are O1 and B1 plus 2. Moving on to 11.2. Show that angle C is equal to 90 degrees. First step, I went on to say angle ODE is equal to 90 degrees. My reason was tangent is perpendicular to radius. That is a theorem. And I went on to say angle C is equal to angle ODE and they are both equal to 90 degrees. My reason was corresponding angles are equal because BC is parallel to OD. I've proved that above. And moving on to question 12. The problem statement reads as follows. In the diagram below, two circles touch each other externally at point P. QPR is a common tangent to both circles at P. EDRC is a tangent to circle PBFC at C. Angle RCA is equal to Y and angle DAC is equal to X. AD is parallel to BC. 12.1. Name with reasons 4 other angles equals to X. First, I went on to say angle P1 is equal to angle A1 and they're both equals to X. The tan chord theorem was my reason. As you can see, that's a theorem that you need to know. Second, I went on to say angle C2 is equal to angle A1 and they're both equals to X. My reason was alternate angles because AD is parallel to BC. As you can see, I've also highlighted that in my diagram. And I went on to say angle E is equal to X. Reason was that angles in the same segment or angles subtended by the same chord, and I've highlighted as well in my diagram as you can see. And finally, I went on to say angle P5 is equal to angle P1 and they are both equals to X. My reason was vertically opposite angles and I have obtained the 7 marks. Moving on to 12.2. Show that angle EPA is equal to x plus y. First step, I went on to say angle DCB is equal to x plus y. As you can see that I've highlighted that on my diagram. And I went on to say angle D1 is equal to angle DCB, which are both equal to x plus y. And angle EPA is equal to angle D1, and it's equals to, and they are both equal to x plus y, angles in the same segment, as you can see, and hence I've obtained that 4 marks. Moving on to question 12.3. Determine the numerical value of x plus y if it is further given that DCTP is a cyclic quadrilateral. First step, I went on to say angle P2 is equal to angle DAC, and they're both equals to y. My reason was tangents from the same point. And I went on to say angle DPT is equal to angle P1 plus angle P2 plus angle P3. As you can see in my diagram, I've highlighted in orange. And angle DPT is equal to x plus y plus x plus y. I've substituted in the P1 plus P2 plus P3. That's where x plus y and x plus y are coming from. Please make sure that you understand, and if you don't, please consider rewinding the video so you can see me explain in the previous parts of the question. But anyway, moving on, I'm going to be left with angle DPT is equal to 2x plus 2y, and angle C is equal to x plus y. I've proved this above, and hence angle DPT plus angle C is equal to 180 degrees. Reason is opposite angles of a cyclic quadrilateral. Substituting in everything I know, DPT is equal to 2x plus y, and angle C is equal to x plus y, and 2x plus 2y plus x plus y will give me 180 degrees, and I'll be left with 3x plus 3y is equal to 180 degrees. Dividing everything by 3, I will get x plus y is equal to 60 degrees, and that is the end of that question, and hence the end of the lesson. Thank you for joining me. If this helped you out, please like and subscribe, and stay tuned for more problems like this. See you in the next one. Cheers.